Hello, ladies and gentlemen. In this lesson, we are going to look at the scale factor and its effects not only on the sides, but also on the perimeter and area. Let's take a look. So we have two figures. One is going to be 3 times larger. So we're going to fill this in. If it's 3 times larger, that would make this side 9, and that would make this side 15. So we're going to fill these in of the first image, number 1, and number 2. The base, I should say, is not 3. The base is 5. And the height is 3. Base is 15, and the height is 9. As we look at what the perimeter is, well, let's add up all the sides. Let's fill this in, 5 and 3. So 5 plus 5 is 10, plus 3 is 13, plus 3 is 16 for the perimeter. And then I know that just to find out what the area is, 3 times 5, so 15. Now from here, I would actually be able to figure out just using scale factor, I'd be able to figure out what the new perimeter and what the new area is without even calculating it up, without adding 9 plus 15 plus 9 plus 15 and 9 times 15. And I want you to notice that when you actually work with these numbers. So the new perimeter will actually be 3 times larger. So 9 plus 9 plus 15 plus 15, that's all going to add up to be 48. What's interesting about the new area, it doesn't just grow by 3. If I were to take this image, the small rectangular prism right here, if I were able to take that and actually put it inside here, I would not only be able to fit it 3 times, I'd actually be able to fit it 9 times. Or if you're ever figuring out what the area is and wanted to figure out the new area, you do times 3 and times 3 again. That's how you figure out the new area. So we're actually going to do 15 times 3, which is 45, times 3 again, which is 135. Now, just to double check, I would do 9 times 15 over here. And yes, that does give me 135. Let's take a look at another example and really try and apply that scale factor, that idea of scale factor, how it affects all of the lengths, the perimeter, and the area. So we have 2 similar rectangles, and we can work with triangles as well. But the scale factor, that's actually what I have to figure out this time. It goes from 2 to 4. So what times 2 will give us 4? A scale factor of 2. Double checking that, 5 times 2 does give me 10. Yes. Okay, so let's take a look at the rest of this. Let's fill in our information down here for number 1 and number 2. Our base, again, just be careful with that, 5 and 2, and our base over here, 10, and our height is 4. Okay, look, it got 2 times larger, 2 times larger. Our perimeter, 2 plus 2, 4, plus 5, 9, plus 5, 14. And I know from the previous slide, from the previous example, this is going to grow by the scale factor, or times 2. So I don't even need to add up all the sides. I can just figure out that that is 28. The area of the original, let's take a look at this. It's just length times width, 2 times 5, 10. And I just want to remind everybody that area is just slightly different. Area is going to grow by the scale factor and by the scale factor again. So we have to do it times 2 times 2. 10 times 2 is 20. Times 2 again, that one is actually going to be 40. Just double checking. 4 times 10, yes, is 40. So let's make some conclusion statements here. Conclusion is, the sides, the perimeter, will grow by the scale factor. Grow by the scale factor. The area will grow by the scale factor squared. By scale factor squared. Or scale factor and then times scale factor again. Apply that to your work after this, and if you need to, rewatch this video and get a better concept of what's going on. Have a great night, everybody.